Hi guys, welcome back to Learn Class 9 Science, and it's me Badri. So today we are with a new topic. Okay, in the previous video you have seen the part 1 of the chapter 1, which is matter in our surrounding, which is a more elaborated version of the old lesson matter around us. So let's go to the video. So already if you want to see my chapter 1 part 1, go and watch that so you understand this video more nice. And this is me Badri. Let's go into the video. Where did we end? From the last part is like the place where we left was that the melting point of ice is 273.15 K. K is basically a unit which is expressed by a quantity and a unit and a symbol. The quantity is temperature, the unit is Kelvin, and the symbol is K. Okay, that is why it's called 273.15 K. Okay, till that we have already completed. So let's go. Okay, you must have observed that during the experiment of melting the ice, when you melt the ice, the system does not change after all. Okay, there's a melting point where the ice melts. Till that there is no change in there's no continue the beaker, that is we continue to supply heat. The heat gets up in changing the state by overcoming the force of attraction. Okay, there is an attraction between the particles which is separated, okay, between the particles, as the heat energy is absorbed by the ice without showing any rise in the temperature. So there is no rise in the temperature without showing, but the ice inside the beaker showing any rise in temperature, it is considered that the ice absorbs the heat, but we cannot see it. It is considered that it gets hidden into the contents of the beaker, and it is known as the latent heat. It is one of the most important keyword. Remember, latent heat, while you melt the ice, for example, in a beaker where the showing any rise in the temperature, it is considered that it rises, but it is considered that it hidden in the contents of the beaker, so we cannot see it. It's called as latent heat. So what is latent heat? Latent heat means hidden. That's called latent heat. So the amount of heat energy need to burn 1 kg of solid into a liquid at the atmospheric temperature is called as the latent heat of fusion. So I have this highlighter which will be around 220 or 40 grams. So let me okay, just for example, take this as a metal highlighter, which is around 1 kg, okay, 1000 grams. So I burn this. Yeah, the amount of heat energy which is needed by me to melt this into a liquid, exactly a plastic, or to melt it into a liquid, is called as the latent heat of fusion. So that is only okay. You have seen that when we okay, we cannot see the particles inside water or any other matter, okay, but when we supply heat energy to the water, the particles move more faster. That's why you see the bubbles forming it and moving there and here. It's because of that particles which form a lot. So the particles move more faster when heat is generated in water because of the kinetic energy, where the force of attraction between the space between the particles is overcome by the heat. Okay, the temperature at which a liquid starts boiling at the atmospheric pressure is known as the boiling point. The temperature is 373 K. That is, what is K? Meaning here K is a symbol of a unit Kelvin, and the quantity is temperature, that is Kelvin. So it is 373 Kelvin, and which is bracket 100 degrees Celsius, the normal temperature of water, that is called 100 degrees Celsius, which is equal to 273. Have you heard about 273 or the number 273 before I told you? Yeah, I told, right, the melting point of ice is 273, so which you need to keep it in it and remove the 0.15 because it's not a big difference, and you're gonna add plus 100, which is equal to 373 K, which is 373 Kel. So okay, we understand that means 373 Kelvin. Okay, particles in steam, like when they evaporate, which comes into a vapor like a steam, that is the water vapor at 373 K, which is bracket 100 degrees Celsius, have more energy than the water at the same temperature. Okay, the steam at the same temperature of the water has more energy, okay, than the liquid. So the particles in steam have absorbed extra energy in the form of latent heat of vaporization. Okay, so let's keep a solid state. Okay, when you heat it, it becomes a liquid state, and when you heat the liquid state, it converts into gaseous state. And when you convert this gaseous state into you cool the gaseous state, it becomes a liquid state. And when you cool this liquid state, it becomes solid state. So it's like a cycle. Okay, so we infer that the state of matter can be changed into state by changing temperature. So this is a solid, I can melt this, bring it to liquid, and more melting, it becomes a vapor. So we can change the shape, like we can change the state of a matter using the temperature, the rise in temperature or decrease in temperature, anything. So the substance around us change state from state to liquid, and from liquid to gas, and application of heat. But there are some that changes directly from solid state to gaseous state. Okay, what is that called? It is called vice versa without changing into the liquid state. Okay, so I have a highlighter with me. Okay, let me give something different. So you have an ice cube. Okay, where you cannot make it directly into a gas without melting it. Okay, I mean like bringing it to a liquid and then bring it into a gaseous form. Okay, but if you take a block of pencil or a plastic or a wood block, okay, the best example, like when you melt it, it doesn't become liquid or anything, it becomes like a carbon and a black, and the smoke comes, which is a steam, which is a gas. So we understand that a change of state directly from solid, like from a wood block to the gas directly, okay, without the help of the liquid, okay, is called as sublimation. A change of a state directly from the solid to gas without changing into liquid state is called sublimation. And the direct change of gas to solid without changing in liquid is called as deposition. Okay, have you heard the word deposition? The direct change of gas to solid. So we saw that solid to gas is sublimation, okay, and gas to solid is deposition, which is really easy. You just need to understand the way. Without the help of liquid direct. Okay, effects of change of pressure. Okay, the difference in various states of matter. Why is there the difference in various states of matter? Because it's due to the difference in the distance between the spaces of the constituent particles. If you see this, you can see the liquid, right? The solid first. You see the solid which is tightly packed. Okay, it's called. Okay, so you can see this. The solid are tightly packed, which make them a group of particles combine and make it strong and a different shape called solid. And second is you can see the liquid where they have little space between them, which make them different from solid because it's little different. And if you see gas, it's actually more space and the particles are moving speedily and more freely. So that's the main difference between the difference between the matter of state of matter. Okay. Applying pressure and reducing temperature can be liquefied gas. Okay, so you know that carbon dioxide, which is actually used by plants to inhale, and which we use to extinguish fire in certain case because it's act like a blanket. Okay, leave that. So do you know solid carbon dioxide? Okay, this is carbon dioxide and this is solid carbon dioxide. So the solid carbon dioxide, where the carbon dioxide is also known as dry ice. Okay, you may even see this dry ice in the Oreo biscuit or the smoked biscuit, where they dip the biscuit inside the nitrogen and put it in tumbler and shake it, where the gas will go and give it to you, which you eat and you feel like smoke coming out of your mouth and nose. It's because of this. So you can see in this video, when you take this gas, it's like an ice cube, okay, which is frozen, and a smoke coming out from it. And when you put it in the water, there's a more number of like gas coming out of it, so you can actually see it here. Okay, it's literally cool, right? But you're not supposed to touch it in your hand because it's a little dangerous and not good. Okay, we can say that the presence of temperature determines the state of substance, where it's solid, liquid or gas. Okay, so you can see a picture over here where you can see the three state of matter: liquid, solid, gas. So first let's start with the solid. So here in solid, from solid to liquid there is an arrow which is called the fusion. Okay, the fusion means when you melt solid like a water ice cube into you eat it, it becomes liquid. It's called as fusion. And when you like freeze that liquid into solid, it's called as solidification, which becomes an ice. Okay, at here when you like heat the liquid, it converts into gas. Okay, so from liquid to gas there's an arrow which is called as vaporization, and when you convert the gas to liquid it is called as condensation. Okay, and then you can go down, which is gas. So from gas to solid is called as deposition. Okay, and from solid to gas it is called as sublimation, which we have already we have seen without the support of liquid. We have already studied the two terms, which is sublimation and deposition. Okay, next. Okay, if you keep, what is evaporation? Evaporation is one of the most favorite chapter for me in our primary age. Okay, there are lots of chapters which came, but I don't remember that all. But I remember the concepts, but I don't know the chapter. But this chapter, how is rain form, evaporation of this, like you can see the childhood memories when you see this. Okay, like that. Water is kept left or uncovered in a pot or a vessel, slowly changes into water vapor. Okay, due to the heat of the sun, temperature increases where the water particles the attraction between them is over, so it forms into a steam or evaporation. Okay, so we know that particles of matter are always moving and are never at rest. Okay, so the phenomena of change of liquid into vaporized, okay, at any temperature below its boiling point is called as evaporation. Okay guys, most of the students make a problem with this between the boiling temperature, the boiling point, and the melting temperature, the melting point, where I already explained in the previous video, in the part 1, what is melting point and what is boiling point. So you need to understand that the phenomena of change of the liquid into vapor at any temperature below its boiling point is called as evaporation. Okay, that's evaporation. So let's go to the next one. So the factors of affecting the evaporation. Okay, first one is an decreasing of surface area. We know that evaporation is a surface phenomenon. If surface area increases, the rate of evaporation also increases. For example, while you're putting the cloths for drying up, we spread them out. It's like close and shrink. And when you put like that, it takes more time to dry. It dries, but it takes more time. And when you spread it and put, it takes less time to dry. So that's an example. Number 2, an increase of temperature. So as the temperature rises, the vapor also rises. So as increase in temperature, with the increase of temperature, more number of particles get enough kinetic energy to get into the vapor state. Okay. The third, decrease in humidity. Okay, what is humidity? We have already studied in our lower classes that humidity is the amount of water vapor present in air. The air around us cannot hold water more than its limit. Okay, and what happens if it holds more than its limit? It cannot. If even it's holding, it may burst and clouds and the water may come. So okay, the air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in the air is already high, the rate of evaporation decreases. An increase in wind speed, it is common. Okay, the fourth one, an increase in wind speed. Okay, you may hear that you should put the clothes for drying outside not during the rainy season, but you're supposed to put it in the normal day or sunny day or windy day. Why it is preferred in a windy day? Because in a windy day you can see that the gas particles are free and there is space between those particles, and this is small dot, which is a particle. When the air comes in, like it pushes, it needs some pressure to push the particle to go more faster. Some particles are thousands and millions of particles, and when the wind comes fast, it takes the particles more faster, and it gets contact in the clothes more faster, and it gets dried more earlier. Okay, so that's why. So that's what. But what is the reason evaporation causes cooling? Okay, if an open vessel or open pot where the water or the liquid is stored in that keep on evaporating, the particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. I'm a human. Okay, so like I have got a homework of writing one page of handwriting, which I write and lose my almost my energy in this. Okay, and I need to regain it. Okay, I'm a liquid or water. Okay, who has lost my energy? So where the particles of liquid absorbs energy from the surroundings to regain the energy lost during the evaporation. So I lost my energy, okay, in writing, and when I drink some juice or some food, I regain my energy and I write again. Okay, at the same way the water needs to regain. So the particles of liquid absorb energy from the surroundings to regain the energy lost during evaporation. This absorption of energy from the surroundings make the surroundings cold. So during summer, after a sunny day, people sprinkle water on the rooftop. Even I have seen this. So I used to go to my grandparents' house during the January to the May month, because it's the season where it's there are more holidays. During the summertime I go, where like it's so hot, you cannot even be in the house, and at night time you cannot even like sleep there. Okay, that time I have seen like everyone evening time sprinkling water on their house, because during the sunset the sun falls on the terrace first before going to the ground. When it like touches the ground, in the terrace, the heat is absorbed by the terrace and slowly comes down and comes to the hall or the living room or the bedroom, which keeps the surroundings hot. Okay, which is a closed wall, and you cannot like live in a place where it's hot. So people like sprinkle water in the terrace, like buckets and buckets, which keep the roof like chill, mostly in the summer season, which keep inside down more cold. Okay, and they even pour it in the open ground. Why? There is no house in the open ground, so why they even pour buckets of water in the open ground and wasting where there is no even plants? So when they put it in the open ground, there are some houses, okay, small houses or big houses near it, like a society. Okay, when they put the buckets of water in the ground, when the heat energy falls on the ground, okay, it's a big ground, right? So when it falls on the ground absorbs the heat and gives to the surroundings where the houses are there, and they feel the hot, so they put the same the bucket of water. And another reason is that if you put the water in a ground, the water is heavier and makes the sand stick together. It's not fertile ground. I'm seeing a playground where the dust comes and goes, so they put water during the summertime, so all the sand particles also go. It's second reason, but the main reason is to keep even the surroundings cold. And during the summer we drink lots of water. Why? Because of the mechanism of our body. When we drink water, it keeps our throat it makes our throat smooth, and it doesn't make our throat dry, and the mechanism of our body keeps our body cool. Okay, and while you go outside, okay, not for playing, I'm just saying for a normal walk or being in your house where like you feel more sweaty, so you're not preferred to wear nylon dress or some other dress. You're preferred to wear cotton dress, which is a light dress. When the sweat comes from your body, the sweat is absorbed by cotton. Cotton is a good absorber. Like when water falls on the cotton, it absorbs. So like the same way, the dress made up of cotton also absorbs the water inside it. Again, the heat comes the same way. The water gets evaporated from the cotton from your dress and goes up the steam way, which is invisible. You cannot see it with your eyes. So that's what you prefer to wear cotton dress, because it absorbs the sweat. And why not nylon dress? Nylon dress is preferred to wear during the 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 workout time or the playing games or exercise, but not during a normal time. Okay, so let us take a tumbler. I have a tumbler with me. Okay, I have put some water in it and keep in fridge. I've not frozen it. I just keep it in the fridge where the water gets cold, and I keep it in the table for just 30 seconds. Then I take it up. You can see a dew drops just in 30 seconds. Then the outermost part, the outermost circle, like over here, the tumbler, you can see some dew particles. Not in this tumbler, but in this picture, where you can see there are some dew drops in this. What is dew? Dew are small drops, okay, and the surface, the water vapor present in the air on coming in contact with the cold glass of water loses energy. Okay, so we know that you can see this gas, right? The gas has a lots of space between them in the particles, and the more free. Okay, so the free particles of the gas are, but they don't have, they need some pressure to push them. That is air which take them. But what is wind? Wind is more, okay, have more pressure than air, which is a small tiny particle, a million of particles. Okay, this is the air which slowly takes them. This is the wind which fastly takes them and make the which make them and take them to the ice. Okay, this tumbler, and it's this tumbler. This tumbler is cold, and the water in the form of gaseous, when it hits this, there is water formed in this. From this water, come to understand there is lots of water content in our surroundings. That is in a gaseous form. Okay, this lesson is over, so let me meet you in another video, and this is the end of this chapter, but there is more some exercise to finish which will come in the next video. And this chemistry lesson is really easy, and all the best. It's me, Badri. Thank you.